Hello everyone, welcome to ashatech.com. In today's discussion, we are going to look at the question in mathematics, which is about differential calculus, and we are looking at the rates of change. So this is VDEE Applied Math 2 UBTEB question April 22. So this question says, the rate at which the temperature T of an electric wire reduces is proportional to the amount by which it exceeds its surroundings. If the temperature of the wire falls from 200 degrees Celsius to 100 degrees Celsius in 40 minutes, and that the temperature of the surroundings is 10 degrees Celsius, part 1 of this question says, show that after T minutes, the temperature T degrees centigrade of the electric wire will be given by T equal to 10 plus 190 exponential of negative KT, whereby K is equal to 1 over 40 natural logarithm of 19 out of 9. Roman 2 of this question says, calculate the time it takes to reach 50 degrees centigrade. Yes, let us look at the part B of this question. It says, form a differential equation from x equal to a cos t plus b sin t. Hence, state the order of the differential equation formed. So having looked at this question, let us find the solutions to this particular question. To solve Roman 1, we are given that the temperature at any time T is T degrees centigrade, and we are going to let the temperature of the surroundings equal to T naught. The temperature of the surroundings is a constant according to what is given, and the temperature T is a variable. So we have to note those two important things. It is given therefore that the rate of change of this temperature, the rate at which it reduces, is directly proportional to the amount by which it exceeds that one of the surroundings. So it means T is at any time is greater than that one of the surroundings. So the amount by which it exceeds the temperature of the wire exceeds that of the surroundings T naught is going to be T minus T naught, which is that T naught is the temperature of the surroundings. And we are putting a negative to show that the rate of change of this temperature of the wire with the time is reducing. That's why the statement is saying the rate of change of the rate at which the temperature of that wire reduces is given by the amount by which it exceeds that one of the surroundings. So the negative shows the reduction in dt, the temperature by dt. So if we introduce equal signs, it means we will create a constant k into t minus t naught. Now we'll proceed. The change of temperature with respect to time, as given above, we can once again simplify it by by correcting like terms together. So if temperature is changing this way, we bring the temperature, or the contents, the constituents of temperature we bring here, and the components of time we bring the other side. So if we integrate both sides, it means we shall integrate integral of dt divided by the integral. It is actually integral of 1 out of t minus t naught dt, which is equal to the integral of negative k with respect to time. So if we remember this kind of integration, if we are integrating fx prime, which is the derivative of x, of f of x, out of f of x, then it is equal to ln f of x. So that's the principle that we are using here. So the integral of 1 over t minus t naught with respect to t is going to be natural logarithm of t minus t naught, and is equal to negative k times t, then plus c, which is a constant of integration. Constant of integration is c. Now, that means if I'm to make t the subject of the formula, because according to what I'm given, I'm supposed to prove something, which is t expressed as some value and another variable here. So let us proceed. You can see that t is equal to t naught, because this is like this. This is like t minus t naught is equal to exponential exponential is exponential of negative kt. This is plus c. Okay, so this would be t equal to t naught plus exponential of negative kt times ec, which is coming to be called a. And so if we use that a, substituting it here, because a is just a constant, just choose it arbitrarily and let exponential of c, exponential of a constant is a constant, so let us assume it is a constant a. So we shall bring it here and find that it is t equals t naught plus exponential of negative k t times a, which gives you something like that. So which finally gives you that. So let us put the initial conditions. That when t is equal to 0, at the time when t is equal to 0, meaning the temperature of the wire is 200 degrees Celsius, and t naught, which is the temperature of the surroundings, we are taking it as a constant, is equal to 10 degrees Celsius. So if we substitute in this expression, it means t, which is 200, is equal to 10 plus a exponential of negative k times the value of t, which is 0. It will give us the constant a as 200 minus 10, which is equal to 90. 190. So let us proceed and put in our expression. Therefore, t, which is the temperature of the wire at any time t, is equal to 10 plus 190 exponential of negative kt, and this is as required. Now let us proceed. Part of the question says that k should be equal to some value. So let us find out what is that k using our expression. Also, when t is equal to 40 minutes, we can also look at the boundary conditions. At the extreme end, we are looking at when t is equal to 40 minutes, what is t? T has been given that it reduces from 200 degrees Celsius to 100 degrees Celsius in 40 minutes. So if at t is equal to 0, temperature is 200 degrees Celsius, it means after 40 minutes, at t equal to 40 minutes, then the temperature t is equal to 100 degrees Celsius. So if we substitute it in this expression of t at any time t minutes, then it will be 100 equals to 10 plus 190 exponential of negative k times the value of t, which is time, and it is 40. So when we look at, when we correct like terms, we find out that it is going to bring you some value, which is going to be 90 divided by, because here I'm supposed to divide both sides, I can divide both sides by 190, so I will have 90 divided by 190 is equal to 190 divided by 190 exponential of negative k 40k. So we cancel this and that, and we will have something like 9 out of 19 equal to negative 40k. So let us proceed and see what happens. So now, for us to solve that, we will find out that to remove this exponential, we can take ln both sides. So if we take natural logarithms both sides, it means I will have ln of 9 out of 19 is equal to negative 40k, because if I take ln, it will be it is like a logarithm base e of e to power 40k. So using the laws of logarithms, it will bring negative 40k this side. So that means, therefore, to remove this negative, I can divide it both sides here, so that it becomes like this, divided by negative 1, so that I have 40k equal to natural logarithm of 1 divided by 9 divided by 18, which will automatically bring you the fact that 40k will equal to natural logarithm of 19 divided by 9. Then you make k the subject of the formula. K will therefore equal to 1 out of 40 natural logarithm of 19 divided by 9. So which is as required. So Roman 2 of this question, they want us to find the time it takes to reach for the temperature to reach 50 degrees Celsius. So it is a matter of now substituting in for temperature. You already know the value of k, find the time t. So if I substitute in, it will be like this. 4 divided by 19 equal to negative kt. We already know k. So k, we can find its constant value, which is 0.01868 from calculator. Then we can substitute it in above for us to find the time t. So when we substitute in our value, in our expression here, it will be t equal to natural logarithm of 19 out of 4 divided by 0.01868, which gives you 83.4 minutes. Okay, let's look at another part of this question, which is B. It is given that x is equal to a cos t plus b sin t. So if we are to differentiate, if we are to get a differential equation out of this, it means we must have complete a differential equation without us finding any challenge with expressing it with this a cos t and all of that. So we must make sure that we differentiate it until when we find that we can replace a particular expression with x. So let us move. If we differentiate this expression with respect to x, it will be the x dt is equal to negative, because the derivative of the cos is a negative sign, so it will be a minus a sin theta sin t plus derivative of sine is a cos, so it will be plus b cos t. Now, if I look at this expression, I cannot get it from x, because if I say it is, if I try to bring x here, it cannot. So I go ahead and differentiate. I look for the second derivative, d2x dt squared is equal to, now I differentiate this with respect to t, it will be minus cos t plus derivative of the cos is a sine, so it will be minus b sine t. So when I look at such expression, minus a cos t minus b sine t, if I factorize out the negative 1 outside, it will be a cos t plus b sine t, and this can take u to be our x, which is given here. So that means I will completely have an equation that is having only the derivative and also this function x. So if I say the 2x by the 2x by the t squared is equal to negative into the value of this whole function, it will be x. So is equal to minus x, and the second derivative of x will therefore equal to negative x. So if I correct it, if I correct the right terms together and send it to the other side, it will become a plus, so that I have the second derivative of x plus x equal to 0, and this is the differential equation that we can get out of our function x, and it is a second order differential. Thank you so much for watching. See you in the next discussion.